ensure compliance with the standards and the interoperability of them. And actually checking them out as a whole and as a system is quite complex because it's a network of federated and distributed systems. So the question is, how do we make sure that the test strategy scales with the complexity, with the addition of requirements, and so on? And as you know, manual checkouts are quite difficult because of the nature of the network and the ecosystem. And it's quite expensive. So if you want to manually test and check out multiple USSPs together, it's very expensive because you need to have everybody at the same time available. Every time one USSP is not able to meet the requirements, you have to start over. So everything is very expensive and not sustainable, neither for the authority nor for the USSPs themselves. And it's unreliable as well because it's human error prone. So since it's people actually running the tests, they may miss one step. And actually, for having practicing it in the SUSE working group, it was actually quite challenging to make sure that all the steps are correctly passed. And the last one is as well, the testing capability is limited because you rely on a human activating the system. So if you want to push the boundaries of the test to more technical aspects, it becomes quite difficult to actually embed that in the test sequence. So here comes the automated test. Here it's actually quite easy and inexpensive as long as the test has been developed. You can build on top of it, and for service providers is actually very nice because you can develop against the test or verify as long as you develop the solution. But as well, you can test your changes against those tests. And the service provider can actually do that on their own, independently of having to coordinate with the other USPs. Because as long as, if you want to test the interoperability, you need to coordinate with other USPs, which is very expensive. And the final point is that you want to allow USPs to innovate. So you need to give them the opportunity to evolve their software at their own pace without actually limiting them to a manual test, which is every 6 months or every year. So you want to have this procedure which is continuously improving, and yeah, that's it.
Yes, that was basically the why of why we have automated testing. Basically, manual checkouts are very difficult. Automated testing is much easier, much cheaper, and so it's got a lot of benefits that go along with it. So what exactly is an automated checkout? A manual checkout is usually what will happen if an authority wants to check and see if its various service providers are providing the capabilities that they're supposed to be provided. So practically speaking, what this will look like is they'll set up a video conference, get all of the service providers on the call, make sure that all of their systems are up and running, and then someone, the test director, will announce various steps of what they want to do. So for remote identification, they might say, USSP1, let's bring up a simulated flight in the test area, and then USSP1 will trigger their simulated flight capability, bring up a flight. So now it's providing remote identification. And then the test director will say, okay, USSP, do you see that flight on your display? So USSP will bring up their little remote identification display, see if the aircraft shows up, check various information about the aircraft, check various requirements. But basically, this is a very manual process. We've got representatives for all of the service providers on the call. You've got the test director manually calling out these individual test steps, and humans are performing a lot of actions. It takes a lot of time, it's very expensive. The automated test is basically this entire process, but with the machines doing all of the work. So the equivalent of the test director saying, USSP1, bring up a simulated test flight in the area, is the automation is going to inject telemetry for a specific test flight that it has in mind into the system. And then instead of saying USSP2, do you see that flight on your screen, the automation is going to ask USSP2's automation, does that flight actually exist in the system?
So similarly to remote ID, so for the flight authorization, we have a similar approach. So the test director in the manual checkout will ask USSP1 to plan a flight in the test area, then ask the USSP2 to try to plan another flight which will conflict with the first one, and check that USSP2 was not able to do that. In the automated testing, the test driver will take care to inject those requests directly into the different systems. The benefit is that if you want to do the combination, another combination of USPs and test actually the full suite, it's actually done in a fraction of time as with an automated test compared to a manual checkout.
So the how that we accomplish this is that we have this big black box of system that we want to test. For network remote identification, that's one thing. For flight authorization, this is a different thing. But we always have this big box of the thing that we want to figure out whether it's working or not. And then down here on the right, we have this big automated test driver. This is the thing that's doing all the tests or triggering the tests and recording all of the data from those tests. The way that these two things communicate with each other and figure out did things go properly is these two interfaces. So the test driver is going to instruct this system to do something. So it's going to send some known data into the system. Like in the case of network remote identification, that test flight, or in the case of flight authorization, that intent, user intent to create a flight. The system's going to do whatever it does. It's basically a black box under test. And then the automated test driver is going to see, did that thing actually work out correctly? So there's another interface where the information from the system comes over through this other interface back to the test driver, and the test driver can evaluate, did that thing actually work correctly? So for network remote ID, we've got injected flight, and then network remote identification happens, and then the automated test driver asks, can I see that flight on various people's screen? For flight authorization, it's slightly different, but the whole concept is pretty much the same for most of the types of tests. The way that we break down these test cases is primarily we try to come up with these simplified scenarios that have a minimum number of steps that really check the requirements that we're interested in testing. So for instance, the little test scenario that we were talking about for network remote ID is a nominal situation. So we test to make sure that nominally, if there's a flight that is injected into the system, that it shows up on someone's display. But there are also other requirements for network remote identification, and they require other scenarios to test. We try to distill those requirements into simplified test cases or simplified scenarios, and then run those scenarios. So then once we have the scenarios, we want to make sure that all of these scenarios cover a set of requirements that we're trying to test. So for network remote identification, there's the ASTM standard F3411. It has a number of requirements for what users of that standard need to accomplish. And so we generally take all of those requirements and we say, okay, well, if we did this nominal test, that'll probably cover this requirement, this requirement, this requirement. We'll go down and make sure all of those requirements that need to be tested are tested by a scenario. So we've got a list of requirements that maps to scenarios, and then we perform the scenarios as test cases. Importantly, not every country or jurisdiction is going to perform exactly the same tests. Certainly for remote identification, we wouldn't want the aircraft to be in country A if we're testing in country B, and there are also various requirements that might vary subtly between countries. And so we actually develop these scenarios on a per country basis. So there's a little example link there if you want to see the test case that we had for Switzerland that was used for the Federal Office of Civil Aviation. And then the most important thing here, the benefit that we get from doing all of this in the InterUSS platform is that the community can provide updates for these tests. So we've got an open source test suite. The test cases are in that open source test suite. And so we can build on aviation's history of sharing learnings to improve safety. And people can propose pull requests in the standard open source flow. They'll be reviewed by the appropriate people and then merged in to the shared test suite so that everybody gets the benefit of the learnings from those individual additional tests.
So this is an example of it's a sequence diagram showing the specificities of the nominal planning tests. So as you can see, the test driver communicates with three other components in the system. The first one is the first USS, which will move first. Then the USS, which is expected to be blocked by the first operational intent. So the first request from the test driver will be sent to the first mover USS, asking him to create an operational intent. And the expected result of this operation is actually captured and is expected to be a planned flight. After that, we check actually that the flight was properly planned in all the different components. So first, we check in the DSS. The DSS is actually responsible to store the status of the airspace, but just references. And then the details of the information of the airspace is actually a peer-to-peer communication. So that's why we actually check to the USS the details of the operational intent. So those two steps are validating that the operational intent was properly planned, and then we check for the conflicting for conflicts. So we communicate or we instruct the second USS, the one blocked, to inject the flight, and with various different conflicting attributes. It can be time, altitude, for use space priority, and area as well. And the expected result is conflict with flight. The outcome of this test is actually a report. This report is machine readable. It's a JSON file which can be transformed in anything you want. But basically, the important thing is that there is a schema, and all the tests will then fit this schema so it can be compared over time. And it will be the same for the full ecosystem. So if all the USPs actually run the test, they will get the same, hopefully the same result, but at least in the same format. The report contains the description of the full system, so versions of the test driver, versions of the tests themselves, the version of the different components as well, and as well the capabilities each USP can have deployed. And then the important part is the list of issues which were detected, and there we have a summary and description of the issue, which check was run, which check were actually not passed or failed, and then the requirements linked to this test. So we have a good idea of what is broken in the standard or the different requirements we need. The severity of the problem, depending on the severity, the test may stop because it's actually can create problems in the next steps of the tests. And finally, we capture all the interactions as well. So even if for each request, you will get the details of how it was called, what was the response, the performance as well, so the latency, the duration of the request, and we could improve the number of informations with that. One nice thing with the automated test, I don't think we mentioned that, we mentioned it quite clear at the beginning, is that the USSP can develop with the test driver inside their build pipeline, and this is what Ben is going to show us now.
Yeah, so the really important thing, or one of the really important things that this does, is enable modern software deployment in the aviation context that we have here. So what this diagram is showing is you kind of start out over on the left side here and develop new features, and then you start pushing and testing them to the right. So there might be some kind of internal process where you automatically build the software and do some internal tests. There might be a staging environment internally to make sure that everything works better, maybe using some more manual tests. And then the key thing over here is this environment here, which might be something a little bit new relative to other paradigms. We want to get to production over here. In production, the end users get to use the software. This is the normal kind of standard thing. But before we get there, we've got this shared partner qualification environment. And this is where automated testing really shines. So if this USS wants to develop this feature, they'll go through all of their normal internal development processes, and then they can push it out to the shared partner qualification environment and then run the automated tests there. And the automated test tests it not only itself, which we can do internally, individually, but it also tests to make sure that there's interoperability between all the other USSs as well. And there's also a traceable record for the regulator that says, I use this software version, I ran the automated tests, they checked all of these requirements, it passed those requirements. So that software version should be good to go to production. This is kind of like the intermediate phase in the manual checkout, but because we've automated it, as often as USSs want to push features, they can do that very easily. So that we don't need a new checkout in order to push out new features. They can go through this pipeline as often as they want, and then this checkout, the automated checkout here, the automated testing, is very easy to do, very cheap to do, so they can get that feature qualified, make sure nothing else breaks in the ecosystem, and push that out to production much more frequently than you would be able to without automated testing.
Perhaps just one more thing on the previous one. The ability of releasing often the code is quite important as well in relation to cybersecurity. You want to be able to patch your code as soon as possible. So by allowing by leveraging the automated test, you can actually quickly update the dependencies, verify that actually all the features and requirements are still met, and safely actually roll out the new version, which will patch hopefully the vulnerabilities. So we have a few cases where the automated test was pretty successful. The first one was automated remote ID, which was implemented and actually implemented on the USP side by Avision. Then we actually worked on the strategic conflict detection as part of the SUSI working group. And in that case, we actually practice the manual checkout and then built the automated checkout out of it. And now we can actually run the automated checkout with Andra, Avision, and Drone Tag as well as with the DSS. And this is something we will be very happy to show you just after the talk. If you want, we can open the screen and run the checkout for you. Then the automated testing as well for the DSS. So SkyGuide joined Wing in Switzerland as a DSS, so they were pulled together, and that the deployment was validated by the testing as well.
So we've got a lot of things that are done, but we've also got things in our future. So some of the things that are on our roadmap is that we want to expand test cases that we have. Right now we have the basics of both remote identification and flight authorization, but we want to cover all of those requirements. We had mentioned earlier that we've got the big list of requirements that translates into the scenarios, that translates into the actual tests that are run. We need to build a few more scenarios to fully cover all of those requirements, and so that's in the expand test cases item. We also want to do deeper root cause reporting. Right now, remote identification doesn't figure out exactly where the problem was, and there's some easy things that we can do there in order to improve that a lot. We also want to make sure that we're testing all the 4 mandatory use-based services, and so we've got network remote identification and flight authorization covered currently, but we want to add a geo-awareness and traffic information to make sure that we're ready for that use-based rollout in 2023. And finally, we want to expand the accessibility and ease of conducting automated tests. Basically, just make this easier to run, make it as accessible as possible for anybody who wants to use this functionality to make the deployments easier and safer and more effective. So I think that's pretty much the overview of InterUSS from an automated testing standpoint. Does anybody have any questions? I think there's a microphone there. We'll go around.
Mine's a simple plug. It got cut off on the bottom of the screen, right? It's a Linux Foundation open source project. How can people help? How can people get involved? How can people contribute to this? If you can share a little bit about how they can find out more about the technical steering committee.
Yeah, the best place to go for kind of an entry point into all the things InterUSS is InterUSSPlatform.org. That has a bunch of information about the project itself and is the best starting point for getting involved in an organization level. If anybody is interested on a more technical level, the best entry point there is our GitHub project. So it's github.com/InterUSS. That's the project. And then the primary repository is /DSS. So either of those will get to the primary technical entry point.
Okay, it's not really a technical question, but in Switzerland you're using this as part of your process of qualification and certification. Is this being accepted as a reasonable method for certification? Can you put it into the bigger context? If another European country wants to certify, should they be following this method?
Okay. I'm not very comfortable to answer this question because I'm not FOCA. However, I know that the ambition is to actually leverage as much as possible the automated tests because the idea is that this is the only way that this will be sustainable for the authority.
So to answer, yes, ESA is evaluating this feasibility to expand that approach for any USSP in Europe. That's a wish, and we'll see if it's achievable, if we can enforce that through an ANC or whatever. That's an intent. Yes, we are hardly working on that. That's some questions, technical question. Are you able to simulate the communication between CIS USSPs or inter-USSPs in your environment? Maybe data coming from other sources than the USSPs. So to which extent are you able to encompass the external world? ETS is what we're doing.
Yeah, I think basically we want to shoot for test any of the things that we need to test. And so in the case of network promote identification and flight authorization, that's mainly USSP to USSP communication. We know that for geo-awareness, the geo-awareness data is not going to necessarily come from another USSP. It'll come from whatever the sources are that it comes from. And so we want to design a test around that so that wouldn't exactly test the communication between those two interfaces, but it would test the outcome of that communication between the interfaces. And so I think that basically the answer is a qualified yes. Awesome. Well, thank you very much for coming. We appreciate your time.